Hello and welcome to this video all about circle arcs and the perimeter of circle sectors. So before we look at that, just a quick reminder of those key circle formulas. So the area of a circle is always pi times the radius squared, circumference is always pi times diameter, and remember, it's really important, the diameter is always double the radius. Now, two of these formulas you will get on your formula sheet in the 2024 exam, so the area and the circumference formulas will be on there if you are sitting your exam in summer of 2024. So you might be wondering what a circle sector is. Well, a circle sector is essentially a slice of a circle going from the edge of the circle to the middle. Now, it's really important that it goes to the middle of the circle, otherwise it would be a circle segment rather than a sector. And in terms of what an arc is just essentially part of the circumference. So it's just a part of the edge of the circle.
Okay, so here is your first example. I'm going to start by looking at semicircles. So what I'd like you to do is pause your video and work out the perimeter of this semicircle. Okay, so here is the solution to this. So if we do pi times 20, that will give you, so just down here, just let me get my pen, pi times 20, that will tell you the circumference of a full circle with the diameter of 20. So this is your full circle here. But when you divide it by 2, which is you've done here, that tells you the arc around the edge. That shows you, I'm not drawing that very well, but that tells you the arc around the edge of the circle. But for the perimeter, remember, perimeter is always the distance around the edge of a shape. We've got to include that straight edge at the bottom, so that diameter. So that's why we've got to add this 20 on. And I'll show you, just so you can clarify, how to type this in on your calculator. So you do press shift, there we go, shift, your pi button is down here, pi times 20, so it will always tell you in terms of pi first, divide by 2, so it's 10 pi if you were doing it in terms of pi, then add on your 20, and there we go, we can see the full length answer there, but to one decimal place it would be 51.1.
So here is your second example then on semicircle. So I want to know what the perimeter of this semicircle is, and this time it has a radius of 6 centimeters. Let's take a look at the answer then. So first of all, we need to know what the diameter is. So if we do 6 times 2, that will tell us the diameter of this semicircle. Then we can do our sum. So remember, same as last time, pi times 12 will tell us the full circle. That's the whole circle. When you divide by 2, that will only tell you the arc. This will only tell you the arc length around the edge of this semicircle. So we've got to add this straight edge on here, this 12. Always remember to add your straight edge on if you're being asked to do the perimeter. And that will give us an answer of 30.8 centimeters. So on this next question, we're going to look at a quarter circle with a radius of 8. So once again, pause your video and have a go. Okay, let's take a look at the answer to this then. So first of all, we need to double our radius because we need to know the diameter. Whenever you want to know the arc length, you do need to know the diameter. So we double that to get 16. Then we've got to do the part on your scientific calculator. So if we do pi times 16, so this bit here will tell you the circle. So that will be a full circle's circumference. Then when we divide by 4, that gives us just our arc length, which is that curved edge. Then we just got to add on our straight edges here. So you always got to make sure, remember, like I've said on the previous two questions, that you add on your straight edges at the end when you are doing the perimeter of any circle sector. Okay, and that will give us a final answer of 28.6 to 1 decimal place. So we're now going to move this on to look at circle arcs. So there's this formula that you can remember for circle arcs, which is arc length equals angle over 360 times pi times diameter. So remember that when we're doing the circumference, that's always the pi times the diameter. So that's why this is included within this formula. But when we include this fraction here, or we can write it as a division if you prefer, that basically works out the proportion of the circle that we had. So for those three examples we were looking at, we were doing either a semicircle or a quarter circle. So with the semicircles, they have an angle of 180 degrees. Well, that simplifies down to a half, which is why those examples are a little bit more straightforward, because we could just half it. But there might be questions where perhaps you don't have a nice straightforward angle that goes into 360 nice and easily. So let's have a look at a couple of examples then relating to this. Okay, so here is your first question then. So I've split this into two sections. What I'd first like you to do is work out just the arc length. So that is your curved edge on the outside of this circle sector. And then I'd like you to do the perimeter of the whole sector.
Okay, so let's go through the answer to this question then. So first of all, we've got the diameter there. So the diameter is 24 because this 12 centimeters only shows you the radius because it goes from the edge to the center of the circle. So we need that. Then this is where we use our formula. So our angle there is 60. So we could write it like this on our scientific calculator. So we can use our fraction button. So you press your fraction button, 60 can go on the top, 360 on the bottom, arrow right, times pi times 24. That will usually give you your answer in terms of pi. If you press SD, it will tell you what the answer is as a number. So to 1 decimal place, this one would be 12.6 centimeters. One thing you can also do as well, if this comes up on a non-calculator paper, which it could do, we could do something to make this a little bit easier. We can simplify this fraction. So we've got 60 over 360 there, which is the same as 1/6. So if you were doing this on a non-calculator paper, you might do it like this. Pi times 24 is 24 pi. 24 pi divided by 6 will give you 4 pi centimeters. So just bear in mind that if it comes up on a non-calculator paper, it's likely you're going to have to do it in terms of pi on that one. Okay, let's add to this then by looking at the arc length. So the first part of this is the same. So we've got to double the 12 to get the 24 centimeter diameter. Then the first part of the sum is very similar. So we've got to do 60 over 360 times pi times 24. So the same way that we did for our arc length. The only extra bit we've got to do is this bit here, where we've got to add on the 2 straight edges there. So you've got the 12 centimeters that's already labeled and this 12 centimeters here. And that would give us 36.6 centimeters.
Okay, let's have a look at our next example then. So again, I'd like you to do the arc length and then follow that up by calculating the perimeter. Okay, let's first look at the arc length then. So here we've got a radius of 13 centimeters, so we need to double that to get the diameter of the full circle, which is 26. Then we've got to put the angle into our formula here. So we've got 150 over 360 times pi times 26. And that will give us 34.03 centimetres. Okay, so your second part to this then, looking at the perimeter. So your first step is the same. We need that diameter of 26 centimetres there. And then we've got the first part of the formula, which is the same. So we've got the 150 over 360 times pi times 26. But we've always got to remember, when you're doing the perimeter of any circle sector, you've got to make sure you add your straight edges on at the end. So we've got those two 13 centimetre straight edges there. And that will give us 60.03 for that one. Okay, final example then. So I'd like you to do the arc length for this one and the perimeter as well. So here is your arc length. So if we double that radius of 18, we get 36 centimetres for the diameter. And then we've got 40 over 360 times pi times 36, and that will give us 12.6 centimetres. Then for the perimeter, same first step, we've got the diameter of 36. Then all we've got to do is just add on those two 18 centimetre straight edges there. So we've got 40 over 360 times pi times 36, and that will give us a perimeter of 48.6 centimetres. And that's your final example on this video. So thanks very much for listening. Bye bye.